Hey guys, welcome to question MM236 of the Maths Methods Fortify study guide. So, this is a pretty long question, 10 marks, but let's just smash through it. So, we've got Leah owns a fruit orchard. She has a vacant rectangular block of land, which is this section here, which is 3 kilometers long and 1 kilometer wide, as shown below. She's trying to decide what to do with the land. Her house is at point O down here, and there is a greenhouse at point G up here. So there are bitumen roads along the perimeter of the land on the lines OE, EG, GH, and HO. And there's a dirt road which is to be built along OF, just straight through the land. Leah needs to come up with multiple designs for the layout of the land to show her husband. They will then decide which design suits their needs. So part A says Leah's first design is created for the purpose of travelling to the greenhouse in the least possible time. They drive to the greenhouse many times each day and do not want to waste time. So, first part, if Leah can drive along dirt roads at 60 kilometers an hour and along bitumen roads at 100 kilometers an hour, show that t equals 1 on 300 times 5 root x squared take 6x plus 10 plus 3x, where t is the time taken for her to get to the greenhouse along the path OFG. Alright, bit of a handful, a lot to take in there, but let's just break it all down. So, we're traveling along this section here. And we need to work out the time it's going to take her to go along this section, right? So along the dirt roads, so along OF, she can travel at 60 kilometers an hour. Along the bitumen roads, so anywhere along the perimeter, but specifically in this question from F to G, she can travel at 100 kilometers an hour. Whoops, not 1,000 kilometers an hour. Awesome. So OF, 60 kilometers an hour, FG, 100 kilometers an hour, right? Because we're taking the path OFG. So first things first is we know that our speed is given by distance over time. It's one of our biggest kind of fundamental concepts in this question, which means that time is equal to distance over speed, right? So just rearrange this. Our total time taken, is going to be equal to the time it takes to get from O to F plus the time it takes to get from F to G, right? So our distance of OF over our speed along OF plus our distance of FG over our speed along FG, right? So we know that our speed on OF is going to be 60. We know our speed on FG is going to be 100, but we don't know the distance of OF, right? We actually do know the distance of FG, that's X kilometers, but we don't know OF, so we're going to need to work that out. So OF we can treat as a hypotenuse to this triangle OEF, right? So we're going to look at this as its own triangle, and we're going to figure out what this distance of OF is. So in order to do that, we're going to need our other two sides. So since GH is 1 kilometer and this is rectangular, this is also going to be 1 kilometer, so distance is 1. We know that the total length of the paddock is 3. We know that FG is equal to X, so this section here must be equal to 3 minus X. Right, so if this whole thing is 3 and this is X, this has to be 3 minus X, which means that OF is going to be our hypotenuse for that. So according to our Pythag, a squared plus b squared equals c squared, which means that c squared, or actually, you know what, I'm just going to rearrange this, which means that c is equal to the square root of a squared plus b squared, where our c is equal to OF in this case. So OF equals the square root of a squared, so 1 squared, plus b squared, which is 3 take x squared. Cool. Awesome. So from here, I'm just going to get rid of this. So just keep in mind this total distance formula. Actually, I'm going to leave that there just because it is quite important. Which means that expanding all this out, expanding this out, we get OF is equal to square root of x squared take 6x plus 10. And that's our first mark. So this is a 2-mark question, and this is where our first mark comes in, which is finding the distance of OF. Cool. So from here, we can actually say that our total time, just using this formula here, is equal to our distance of OF, which is this, x squared take 6x plus 10, over our speed along OF, which is 60 kilometers an hour, so 60, plus our distance of FG, which is X, over our speed along FG, which is 100. Awesome. And now what we're going to do is actually rearrange this to get the format that we want. So we actually want to show, so we want to keep this in mind the whole time. We want to show that t is equal to 300 outside of 5 root x squared take 6 x plus 10 plus 3x. Awesome. So what we're actually going to do is we're going to take out a common fact. Well, we're going to make these denominators equal 300 so that we can, well, okay, let me rephrase that. We want to take out 300 as a common factor to begin with, right? Because we can kind of see this starting to take shape, but we need to do something else first. So we're going to take out 300 as a common factor. So what do we need to do to this in order to make that, this is 1 on 300. So 1 on 300, awesome. So what do we need to do to the top to make our bottom equal 300? Well, we need to make it equal, actually, you know what? Let's rewrite this with a denominator of 300 because we're going to need to take 1 on 300 out as a common factor. So if we've multiplied 60 by something to get to 300, what is that? We've multiplied it by 5, right? Which means that this is the same as 5 root x squared take 6x plus 10, because this 5 and this 300 can cancel to get over 60, right? If we've times 100 by 3 to get to 300, we also need to times the top by 3, which means we get 3x over 300. So now we can take 1 on 300 out as a common factor, which means we get 1 on 300, 5 root x squared take 6x plus 10 plus 3x, which is the answer that we wanted. So it told us, the question told us, find that t equals this, or show that t equals this. And we've found that, which means that we've got our second mark here. That's the end of part AI. So let's move on to part AII. Part AII is also a 2-mark question. And what we're asked to do is find x such that Leah can reach the greenhouse in the minimum possible time. Awesome. So if our time is at a minimum, that means that dt dx is equal to 0, right? You would have probably seen a whole bunch of questions like this before this. So as soon as we see minimum or maximum, we derive, then let it equal 0. So we do have our calculator in this question. You're not going to be expected to derive this by hand. So we're just going to say, according to Kaz, dt dx is equal to x take 3 over 60 root x squared take 6x plus 10 plus 1 on 100. Sweet. So because it's a minimum time, we're going to let this equal 0. So you would do an extra line of working here, but I'm just going to say 0 equals this. And that's our first mark. So recognizing that it has to equal 0 is our first mark. And then we're just going to rearrange this to solve for x, right? So we're going to get negative 1 over 100 equals x take 3, 60 root x squared take 6x plus 10. Now I'm not going to go through all the steps here because I don't think I need to. But this can all rearrange to 0 equals 16x squared minus 96x plus 135. And you do have your calculator here again, guys, so you can just do this in your CAS as long as you kind of show enough working. Which means that 0 is equal to, the factorized version of this is 4x take 15, 4x take 9, which means that x is equal to 15 on 4 and x is equal to 9 on 4. But we have a problem here because one of these answers is outside our proper domain. And what I mean by that is if this length is 3 kilometers and our x is inside that 3, x has to be between 0 and 3, right? It can't be more than 3 because then it would be longer than the whole paddock, which doesn't make sense. And it can't be less than 0, obviously, because we can't have a negative length. So that means that since x is between 0 and 3, x is equal to 9 on 4 kilometers. which is our final answer. So that's our second mark. And we've actually found the X value that Leah can reach the greenhouse in the minimum possible time, which is it. So let's move on to part AIII. And this part asks us, how long does it take Leah to reach the greenhouse with this design? Awesome. So part AIII, and it's just a 1 mark question, so it's going to be pretty quick. You actually have a 1.5 minutes to do this. So what we're going to do is, we know that X is equal to 9 on 4, based on our previous question. And we know that the time taken to reach the greenhouse is given by this formula here. So all we're going to do is sub in this value of X into this equation. 1 on 300, 9 on 4 squared. Take 6 times 9 on 4 plus 10 plus 3 times 9 on 4. Awesome. We're going to sub this into our calculator because we have that and it's only a 1 mark question, so you don't need to do this by hand, which means that T is equal to 13 over 300 hours. And we need to give our answer correct to the nearest second, which means that we need to do this multiplied by 60 to get our minutes, which means that we get 2.6 minutes. Awesome. And to find our nearest second, we do 0.6 times 60 to get our seconds, which means that we get 2 minutes and 36 seconds. That's our first and only mark for this question. The biggest thing here is just making sure that you do answer it correct to the nearest second, because it is it's easy to make the mistake and not do that. But that's it for this question. That's our final answer. So let's move on to part B. Part B is now going to be focused on area. Okay, so part BI is 2 marks. And we've got a bit of a new context here. So we now know that this area separated by the dirt road is A1, this area is A2, and Leah is trying to come up with a new design. So actually, let's just get rid of this as well. Sweet. So her second design focuses on the fruit trees that will be growing on this plot of land. She creates this design such that she grows apples in A2, so apples here, and oranges in A1, in this area here. A1 and A2 are separated by the dirt road OF, and part I asks us to express the areas A1 and A2 in terms of X. Awesome. So let's just start with A1. It's a logical thing to do. A1 is a triangle, right? It's this triangle here, which means that our area of it is going to be half times base times height. Our base is this side here, or it doesn't really matter which side, but let's just call our base this side, which has a length of 3 minus x, right? So base is 3 minus x, and our height is 1, which means that our area of a triangle, or A1, is equal to 3 minus x over 2. Sweet. That's our first mark. So this is a 2 mark question, and we get 1 mark per area that we find. Now, A2, there's multiple ways we could do this. We could split this up into a triangle and a rectangle and find both of them and add them together. But we can also see that this is actually a trapezium. So we can use our trapezium formula to find this. The other thing you could do is actually just do the total area of the paddock minus A1. There's heaps of ways to do this, but I'm just going to use our trapezium formula. So our trapezium formula is the height times A plus B over 2, right? So the height of our trapezium is 1. So 1 times A, which is our first length, 3. B is our second length, which is this bit here. So X over 2, which means that our area 2 is equal to X plus 3 over 2, which is our second final answer for A2, second mark, and that's it for that. So just the biggest thing is our triangle and our trapezium and just breaking those up. But that's part BI. Let's move on to part BII. Part BII is a 1 mark question. Awesome. So The question tells us that Leah sells twice as many apples as oranges, so the ratio of A1 to A2 is equal to 1 to 2. Right, so she sells twice as many apples as oranges. So this area is going to be twice as big as this area, okay? So find the value of x, which will create a 1 to 2 ratio between A1 and A2. Awesome. So we know that if this is double A1, 2 times A1 is equal to A2, right? We know from the previous question that A1 is given by 3 take x on 2, which means that 2 times 3 take x on 2 is equal to our area 2, which is equal to x plus 3 on 2. Awesome. Now 2 times this is equal to 3 minus x. So 3 minus x equals x plus 3 over 2. Multiplying both sides by 2, we get 6 take 2x equals x plus 3. Rearranging this, we get 3x equals 3, which means that x is equal to 1. That's our first and only mark for this question. All it asks for, actually we need to put in units as well. X equals 1 kilometer, because it asks us for the value of x. And that's it, yeah, first and only mark. That's it. So we just need to make sure that we have the ratio right and that we're multiplying the right one by the other one. But the easiest way to do that is just to think like A2 is double A1, which means 2 times A1 is equal to A2. Sweet, let's move on to part B, III. So part B, III is, again, a 1 mark question. And we're tasked to find the length of OF in this case. Okay, so we know that x is equal to 1. So x equals 1 kilometer. And we know that the length of OF is, again, the hypotenuse of this triangle, right? So this triangle is equal to 1 and 3 minus x, and we're looking for OF, which means that OF is equal to the square root of this squared, so 1 squared plus 3 minus x squared, according to Pythagoras. Oops, 3 minus x squared. And we also know that x is equal to 1, right? So 1 squared plus 3 minus 1 squared, which means that we get the square root of 1 plus 3 minus 2 is 2, 2 squared is 4, so 1 plus 4, which is the square root of 5 kilometers. It's our final mark, well, first and final mark, and our final answer. So we just need to make sure that we include our kilometers, as in our units, because we're talking about length. But that's it for part B, III. And now we can move on to part B, IV. So part B, IV is, again, another 1 mark question. And we're asked, how long will it take Leah to drive to the greenhouse if her second design is implemented? Awesome. So we're actually coming back to our initial time equation, right? Of t equals 1 on 300, 5 root x squared takes 6x plus 10 plus 3x. But this time we know that our x value is equal to 1, right? Because a1 equals the ratio of a1 and a2 1 to 2. So our x value being 1, we simply sub in our x value for 1 plus 3 times 1. And guys, this is a 1 mark question, so we can simply just plug this into our CAS. What we get is 5 root 5 plus 3 over 300 hours. Now, it hasn't asked for decimal places, which means we have to leave it in this exact form, which means this is our first and final mark for T. And that's it. So we just need to recognize that we need to go back and use our time formula, because they're still taking the same path. It's just OF has just kind of moved a little bit based on the ratio of A1 and A2. So guys, that's it for question MM236. Please hit me up in the comments below if you have any questions. But otherwise, thanks for watching and have an awesome day.